Now, in our long-running series on transients, you now have a new paper on a newfound transient in a photographic plate taken in 1952 at Palomar with, I assume, the Hale telescope, which at the time, that was the most largest and advanced telescope we'd ever built. It was state of the art. And yet there's this transient there where in one plate you see essentially three objects that look like stars. And then a plate an hour later, nothing. They're gone. Tell us about this new paper regarding this particular transient.
This is a new paper that is actually led by my colleague Enrique Solano at the Center of Astrobiology in Madrid. And he has discovered this image where you see three very bright and beautiful stars. And they are there in that unique plate, but you cannot see them ever again, not even 1 hour later. And these three stars we wanted to find with the largest optical telescope because we thought maybe they just got much fainter. So we used the Gran Telescopio Canarias, which is a 10.4 meter optical telescope, and we looked there, we went very deep, and we found nothing. So they really vanished. And they look real. And it seems to be like another case of the so-called multiple transients that we've been seeing before.
Now, you've written previous papers on this where there are other transients. What makes this one, and I actually know the answer to this question, but what makes this one especially compelling?
It's so bright, so beautiful, so star-like. Because with the previous ones, like when the first case we found, they were very faint. We were wondering, okay, maybe it's some kind of plate flaws that have some very unusual, coincidentally star-like shapes. But again, they were quite faint and close to the detection limit. And now you see three super beautiful stars that are there and later vanish. And that is the kind of thing that we reacted on.
So what magnitude are we talking about as far as brightness goes?
I think 15 mag, more or less.
Which for that telescope, that's solid. I think what could a telescope like that?
15, 16 mag to be more exact.
Yeah.
But it's solid.
And they all appear to be the same brightness?
More or less, yes. It's a little bit difficult to get the exact magnitudes of the two ones that are in the crowded region because they are overlapping. But they seem to have more or less the same brightness, all three of them. Maybe the one in the back is slightly fainter also, but yes.
What strikes me about this is that does not look like a plate flaw. That looks like stellar objects. And that should be there set in stone, so to speak. But that's not what this is, right?
Exactly, because when you have something very faint, you can always try to say that it's a plate flaw, and then suddenly you have these three super clear stars, and they don't look like plate flaws. But of course, we will always find someone who is going to say, but it probably is a plate flaw. And I think that is why we need to confirm this phenomenon with entirely different methods that have nothing to do with photographic plates. But they look very authentic.
Now, in your work, you look at photographic plates, and I'm sure you see plate flaws and the characteristics of them. So what does a plate flaw actually look like usually?
No, but plate flaws usually looks like random shapes, lots of random shapes. So in order to get to look like stars, you would need to have a very specific, it would have to, a lot of different factors would have to align up, if we say like that, to make it look like a real star. So I think it's a very, very improbable event. And now to find several of them that look like stars is even more improbable. So that's the thing. And I would also expect that if you have, let's say, 10 very bright plate flaws in one plate, you would see some things that are a mix of different forms, but not that it would only look exactly like the stars in the field. So I don't know if this rant made it clearer.
It did. Now, what about exposure time? In other words, how long was the shutter open on the plate that shows the transient? How long was the shutter open to, sort of eliminate any movement that might be there? Because they appear to be point-like.
50 minutes.
Yeah.
It's a 50 minutes exposure time. So if something would be moving in and out of the image, it should be leaving an elongated streak. It's not going to be, let's say it moves fast. If it moves fast during this 15 minutes, so fast that it can go out of the plate and move somewhere else, you're going to have a streak, not a point source. Now, if it moves very, very slowly, then so slowly that it leaves a point source in the red image, you would also see a point source in the blue image that is taken 1 hour later. But you don't see that. What you see is really a point source only in one image and nothing in the other. So how does that happen? That is a question.
Yeah, you have to wonder that. I mean, stars don't just disappear. They don't blink out. Well, at least as far as we know. Hopefully. Well, what about things like a really, really weird event, like a gravitational lensing effect? In other words, a naked black hole passes by lenses some normally very dim stars that are out of the reach of the telescope, and you see them very briefly. What about natural, weird things like that with especially gravitational lensing?
So we've been thinking about it for this particular case, because imagine if you have this gravitational lens that is very, very massive, and suddenly behind this lens you would have a short transient, something that flared up just for a few minutes. Maybe what you would see as an observer would actually be that you would see this transient through the gravitational lens, and it would give multiple images. This is one of the thoughts we were having. My colleagues estimated like what would be the possible mass of the lens, and they concluded something like 10 times the Milky Way mass. 10 times the mass of the Milky Way black hole. And I'm not sure. We are not gravitational lensing experts, and I don't know if this is a reasonable or not reasonable scenario.
It has to be said, though, looking at the image, it does look like an Einstein cross, you would expect. But at the same time, when you see those, it's usually the entire mass of a galaxy bending that light and making that effect when you see it with like a quasar or something like that. And it would seem to me that, that's an implausibly huge black hole to be not at the center of a galaxy. But it's you have to look at all angles and see what might be there. Now, what about other options with this? What other ideas have you guys come up with that might explain this?
Well, I still think that there is an option of that we are seeing something, either some reflecting the sunlight or that you see something with its own intrinsic light that is fairly close to Earth. Why you see it like happening at the same time? Because, the speed of light is limited, so it's not going to come from a galaxy far away, but it's likely to come from inside the solar system.
Though you gotta wonder though, if it were like an asteroid or something like that had varying albedo and you just happen to catch it, but how did it happen that it had 3 lobes? It just seems
no asteroids. Well, I'm thinking more about maybe something artificial, possibly as a possible hypothesis, something with either, again, its own intrinsic lights or lamps or something, or maybe something reflecting the sunlight, and let's say something very flat, very like glass or metal or so.